Good afternoon, all. Thank you for joining our today's webinar on advanced beauty features and techniques. I'm Saira, working as a team lead here at GSAS Metro Systems. Let us get started. And this session and recording, if anyone having any questions or queries during the presentation or during the demonstration, please put your questions in the chat. We will discuss at the end of the session. Now, let us get started. Today, we're going to discuss about differential pairs, followed by how we can do the length tuning, and how we can use active root feature available inside the RTM, and how you can do the BGA fan out, and how we can use a gloss and a retrace panel, which was introduced in the latest version of RTM Designer, and other features like contour routing and snake routing, as well as the component retrace. Followed by, we're going to demonstrate all the features with examples, and we'll be closing the session with Q&A. Now let us have a look at the different pair signals. The first thing we'd like to talk about is the differential pair. Differential pair signals are basically two signals complementary to each other, meaning that when one is logic high and the other is logic low, in differential signaling, the logic value 1 or 0 is determined by the difference of the two input voltages as shown in the diagram. This technique helps to protect the transmission line from noise because of when the noise enters into the differential pair, it essentially gets cancelled out because of the we have got two polarities of the signal. When it comes to creating differential pairs, alternate allows you the option to create them on the both the schematic side and the PCB side of the things. To place define a differential pair on the schematics, you need to use what is called as a differential pair directive. You must also have the net pair to be named with a net label suffix of ending with underscore n and underscore p. The differential pair definitions are transferred to the PCB via ECO or electronic change order. You also, of course, create a differential pairs in the PCB editor. You can also do this in the differential pair editor region of the PCB panel. All that's needed is to select existing nets for both the positive and negative nets, give the pair a name, then click OK. Also, unlike in the schematic editor, any two nets can be chosen as the differential pair members when they are defined in the PCB editor. You don't need to have a suffix underscore p or underscore n. If you don't define your differential pairs with the directives in the schematics, you don't need to worry. You can have the differential pairs defined in the PCB editor without defining them as underscore p or underscore n. Now, if you look at the length matching in Argent Designer, now I have discussed about the differential pair. You might be knowing about the length matching as well. We mentioned earlier that the logic value of a differential pair is determined by the difference between the two voltages. Due to this behavior, we want our signal pair to arrive at the destination at the same time. The receiver might allow some difference called skew, and the skew can be found in the chip datasheet, but ideally, we would like our signal to arrive at exactly the same time and avoid any skew altogether. To avoid this, we have the ability to tune our signals so they arrive exactly when they should. RPM Center supports both single-ended and differential pair length tuning, and is not and is it simple to use. We just activate the tool from within the PCB editor and drag the mouse until the gauze turns green, as you see here in this GIF. The length of a trace needs to be matched to minimum 70 mm and maximum 75 mm. The accordions that are added can be modified to fit your needs, making space for other routing. And as you see, the length will be adjusted automatically. And we have the same capability available for differential pair signals. Here you can see we have both positive and negative signals length in the text above the gauze. Now let's talk about the active route inside the Alten Designer. Active route is not an auto router, but it is similar. It's an automated interactive routing technology. It does route for you, but with your input, we don't recommend you to use it to route all the nets on your board all at once. Like you would an auto router, with active route, you can automatically route individual nets as well as group of nets with a user-defined path or guide, which defines the river along which the new routes will flow. It's worth nothing that active route follows your design rules, works with single-ended and differential pairs. It can route on multiple layers at once, and it finishes your traces with our glossing tool to further reduce the number of corners and shorten the routing. And RTM Designer also have several options when it comes to the BGA fanout inline, staggered via in pad. You can determine the fan out directions. There are several options you can play around with. And what we will show in the demo is fan out a BGA within a room with its own special rules. This is where you can define the rules just for the area around your BGA. In RTM Designer 22, RTM have added a new gloss and retrace panel which can be used to select the gloss and retrace parameters that work best for the selected route that you work with. Before, you had to do a little bit more gauze work when it came to the glossing or retracing. In ITM 22, it must be more easy and you get better results. Just as a note, the gloss tool will be clean up your trace without changing the main part of the route. And the retrace tool will allow you to reroute the tracks. An instance where you should use this is when your width rule has been changed. That means the retrace. And for a last slide, the others just we want to touch upon some other routing features available inside the RTM. We have is contour follow mode, which follows the contour of the board. This is a great for a curved shape or routing situations. There is a component reroute which can enable will reroute the components when they're slightly moved, and there is snake routing which will help keep it uh, equal distance from the other objects on the board, creating a nice curved routing, as well as using the odd corner modes I just discussed, a style of the smooth following a point to point. Yes, now let us switch into the RTM and we'll just uh, see how we can able to use different information pairs inside the schematic and in the PCB editor, and how you can do use Active for doing the automatic routing, BZA fan out, and how we can use cross and retrace panel. We'll just go through a small demo about these features and just switching to the RTM. Yes, I believe most of the attendees here might be using the latest version. If not, the latest version is 22.7. If you are under subscription, please do update yourself to the latest version. This is the latest version. I'm supposed to update, but it's 22.7. Please do update. And I have a schematic sheet open. And if you see at here, we have got two USB signals available. As I have discussed in the presentation, when you have differential pair signals, you should mention in the schematic the net name ending with underscore P or underscore N as the same as we mentioned. In order to define these two nets as differential pair, we have to place directives. Where you can access, just go to place directives and say differential pair, just place it on the this net and place it on the this net. We have got the differential pairs. Now select these two nets and then go to panels and then go to properties. Here we need to define the differential pair net rule for the trace width and the trace gap. Just click on add. We need to define it as a rule. Just click on the rule, and we have got the design rules. Cardinal design rules we can apply in the PCB editor. The same also we can define the schematic editor. Just click on the differential pair routing. Okay, and select OK. Here we have units in mil and mm. If you want to have in mm, just change it to and here you can mention the what is the minimum trace width required. I need to have minimum of 0.1 and minimum gap of 0.1 mm required, and followed by I need to have preferred width of 0.15 mm and gap of the same 0.15, and also I need 0. 35, the same 3.81 is the maximum width and the maximum gap. I want the same. Okay, and just click OK. You can see wherever the design rule is being applied here for these two directives, and then we'll just push this design changes to the PCB. As you know, RTM Designer is a unified design environment. With a single click, we can push your design changes, what you have done in the schematics to the PCB. To do so, go to Design, Update to the PCB. When you say Update to the PCB, you'll be getting a ECO, which is showing what is the design rule is going to add. It will be showing here. Just click on Execute Changes. Just click Close, and if you go to the Design Rules, okay, and if you see there is a rule is being getting added to here, and what is the values you have mentioned are shown here. Okay, and then this is the differential pair. Just go here, interact differential pair routing, and you can start routing these traces. Okay, okay. If you press tab, you can see what is the trace it is been taken. Preferred is 0.15, and if you talk 0.15, you can have to start routing the C. You can see the both are getting identical. Okay, space and the trace width and the entry from the two pads will be identical. This is how we can able to create a differential pair directives design rule in the schematic, and then we can push this design back to the into the ultimate designer with a single click. Now let us see how we can define the differential pairs in the PCB editor if they are not defined in the schematic. For this, let us undo the changes. What now we did, let us remove this and update to, it will remove that things. And if you just have a look at the, yes, we have removed everything. Now let us see how we can define a differential pair inside the PCB data. To do so, first of all, we have to go to the PCB panel. To access the PCB panel, go to panels and say PCB. We have the panel here. It can be talked at any side of the your requirement. The PCB here, and from the drop down, I will seeing a one option called PCB. So differential pair editor. Just select here, and if you click on all differential pairs, nothing is showing here. That means no differential pair has been defined in the schematics. Now we can able to define it by clicking on this add, and here we will be getting a pop-up window which helps us to pick the positive net and the negative net. Just drop down. Yes, we have USB P. USB. Yes, let me type. Yes, we have a positive net and negative net. If you know the net name, just simply type it. Yes, this is net. And then give the meaningful name as it is belongs to USB. I just want to give USB differential pair and then click OK. When I click OK, you can see automatically the tool recognized this two as a differential pair. And here I select right when I enable this option, and when I click on this one, you can see here it is being recognized as a differential pairs. Now I can go here, or I can go to root, interactive differential pair routing. I can pick these two as the differential pairs, and I can complete the routing of these two nets. You can see there is an identical exit and identical entry of the traces which maintain the equal amount of gap toward the process. This is how you can able to create differential pairs in the PCB editor, and you can do the routing. Now let us have a look over the few more about the differential pair routing. Here I have another example by name PC, which will be found in the Altium default installation. Here I have a few differential pair nets. How we can recognize those as a differential pair nets is by seeing the net name, which will be ending with underscore P and underscore N denotes there are the differential pair nets. To do the routing of this, I can go to root and say interactive differential pair routing. Automatically tool will recognize those are the differential pairs, and it will help you to complete the routing of the traces. Okay, and we have the same here. Okay, F2 to come. Now, if you see here, we have got few identical placement and identical differential pages available here. Now, in this scenario, how we can have the same kind of differential pair routing can be performed on this other differential pairs. Yes, what we can do if both the gap and we want to have the same pattern, just simply select and press tab, it will get auto selected, and control C and copy the traces, and you can directly press Ctrl V there to paste it to complete the placement, which will be identical for all these different pairs. If we have the different pairs which are having the same kind of placement and same gap is available, then we can do this process by simply copying the routing of the one which is routed and then pasting it on the others. This also can be performed to save your time inside the RTM designer. This is how you can able to uh, define and complete the routing of the different pairs inside the RTM designer. Okay. Now we just uh, jump into the next thing is interactive length tuning. Yes, as we discussed, if we have a group of signals, we need to maintain a proper length to reach the signal, all signals at a time. Then if you see, this is a USB connector and we have a USB chip and we have nets has been tuned to match the distance of the all the nets. And if you close look at here, we have got a differential, sorry, USB nets of three where they are not uh, tuned. Now, let us see how this has been possible. First of all, we have to set a design rule. If you go to design rules under high speed, and if you go to under matching length, under USB 3, we have a class by name and we have set the tolerance of the nets. All the nets should have a length and the gap, the difference between the each length should be of 1 mm. That's what the rule we kept. And also we have option where you can specify what is the length you require also can be specified here. We have a rule has been applied, and then let us have a look at the what is the length, what is the difference is being proper length, or do we need to do the further length, where you will know the details. The same panel PCB, which will be seen earlier. If you go to the PCB and then click on the next and USB 3, if you see at USB 3 here, this will show the uh, signal length information. You can see all the nets are within the range of 1 mm tolerance, but you can see we have a 3 nets which are out of tolerance. That's why it is showing in orange. Just enable this option called select, and if you click on the net, it will highlight the which net it is. Yes, they are the 3 nets which are out of tolerance, between 13 within the tolerance. Then we should do the length matching. To access the length matching command, we should need to go to root interactive length tuning, or you can access from here interactive length tuning. We'll get a crosshair, just left click on the particular trace and you can able to start doing the tuning. If you press tab, you have got different kind of patterns available. You can able to pick the any one of this which will be uh, recommended for you. Or you can use spacebar to change the between different patterns. Or 3, 4, 2, you can able to reduce the space and less than and greater than, which will be used to height can be adjusted. 1 and 2 is also to be used to reduce the. Okay, like this you can see the red denotes that is not matched. When it turns to green, they are within the range. Okay, like this you can able to easily perform the length tuning. Okay, and here if you want to do some kind of thing, we can able to adjust the trace length tuning like this. And if you want to increase and if you want to increase the inner side, you can able to do the same. And if you want to rotate this one, you able to do that. I think It's not possible somewhere. We'll take, let us, if you want to rotate this, you have to rotate the tuning of your nets as well if you have any space construct. Like that, you can able to do the editing of your traces. You can able to change the state position to adjust the other traces for sufficient gap for others. Okay, this is how you can able to do the length tuning and you can able to adjust the tuning pattern inside the RTM designer. Now let us move to the next topic is active route. As I have explained or I have informed about the active route, which we call it as a guided or automated auto router. Here, we will suggest you to perform your entire board by using auto router. Here in the active route, we have a flexibility where you can able to perform the routing on a group of signals, I mean a net class, okay, which will help you to user finest result. That means user having control to what's the net to be routed on which layer, and also you can define the path for the routing that faces. Whereas in the auto router, we can't able to define the path or pick the nets. Now let us see, and also with the active route, we can perform the length tuning also. Okay. Now let us perform the auto router. I mean active route and length tuning. Let us see. Hold control and just select this group of signals. Okay. Once selected, you will access the active route command from panels and just say active route. You just see here we have option called tool selected. We have already specified design tool. I don't know the glossing and what is the layers which need to be used. We can able to you know taken into consideration for doing the routing. We have given two layers access and you can see the rules and what is the amplitude and what means what is the height of the and what is the amount of gap they should take to perform the routing. Let us give the proper value and you can it also do the length tuning and auto routing for the Differential page nets as well. Now let us perform the active. Now it is been doing, you can see we have option which will support pin swapping, also pin swapping will be supported. And if you want to fine tune the traces, we have a gloss option available. And it will be following the your design rules into consideration and it will be performing it. It won't be taking any kind of rules as the design rules, what you specified based on that for this group of nets, it will be performing the routing. Okay. And as I discussed, once it is completed, we're going to showcase you how you can able to, perform the interactive, differential pair length tuning as well with alpha. You can see here, this bar denotes the completion of the process. As we have selected a bunch of nets, you can see the percentage here and on which nets it's been performing. You can see here, it is been showing, it's almost 91.4% the process completed. You can see the nets are treated with the length tuning based on pattern we have given. And also, apart from the length tuning and routing, we can also define the path. If you set a group of signals you want to route in a specific path, you can define the same. Just hold Alt and select the nets which you want to define, and go to active route. Okay, and then go to route guide. Okay, and you can just by using up and down arrow, you can able to specify the what is the amount of space they can use to complete this process, and then go to active route, and then I want to use same layer as a active route. It will be performing the routing within this uh, uh, path. In this path, you can see the process of the completion here. In this bar is showing what is the amount of percentage been completed will be seen here. I think almost completed. But if you want to route this one with a manual routing, it may take hours, an hour of time. But with the help of this activity, you can see here in the path what you have defined in the layers, it has been taken. See how fast and how efficient it is. but it helps you to route a specific group of signals, but we don't recommend you to do this process for the all your routings. Okay, now let us see how we can able to do the use active route to the differential pair routing and the length tuning. You can see I have a group of differential pair signals. Here I have available. Now I just select all by hold Alt, and then I'll go to PCB active route, and I just can able to select if you require, and you can select the auxiliary you want to have. And just say you can see this route is getting applied, and just say active route. Will be going to perform the routing with the lengthening for this differential pair signals. You can see we have got see how quicker it's been. You can see almost it's been sorry it's been completion. You can see here the process. Now it is performing the glossing as sorry as the routing is completed. It is been performing the glossing of these traces. See how faster and how efficient the tool is in terms of doing the length tuning, and you can see how what is you can see the differential pair mentioning to match the all these signals to be reached to this for connectivity here at the same time. Suppose if you want to adjust this, you can select it, and you can see the uh, and if you want to adjust this one, you can select it, and you can able to do the changes so that we get some kind of space for other signals to okay do the routing of the traces. This is how we can able to do the differential pair routing and length matching with the help of this active route inside the ITA designer. Now let us have a look at the how we can do the BZA fan out inside the ultimate designer. We have the BZIC over here, and based on the number of rows I have, based on that I have taken the layers, and in that I have I think the layers we have leaders new layers. Now to have the fan out, we need to apply a specific design rules, especially for this BGA. In RTM, we have an option called rooms, where you can able to place a room and you can able to define the a design rule for the specific room. To place a room inside the RTM, go to design room and place a rectangular room, and let me place the big okay. I have a rectangular room here. I click escape, double click to open the properties, select the room and give a meaningful name. Click OK. Now I have a room with name BGA. It's been selected. Now, if you look at this BGA, I have a guidance which I have got from these islands. This is a BGA of pitch 0.mm, and I'm taking these values given from this document as a reference to define the clearance, trace width, and the via dia and the whole file. Now let us go into the design rules to apply the specific design rules for this rule. For that, go to design rules, and then the first rule which we need to apply is the clearance. Let me go in order. This new rule is to mention it as a BGA, and we can have a custom query we just mentioned within room. And the same within room, what all rooms we have available in the design will be shown here. Just enter this, pick that room which you want to have, and give the value of the your is required for this BGA, and hit enter. Automatically the value get applied. And the next rule we want to apply is a width rule, just a new rule, and give a name, meaningful name, so that it will be easily understandable for you if you open after some time, or if your colleagues they refer. And here also you have to well, write a different rule within room, and we have to mention it as a DGA, the same. And the trace width here we want to have, 3 min as per the recommendations from the guidelines document. And the next rule is we have to define the routing via style. What's the via dia and what's the via uh, whole we need to have it for this BGA fan out. And here also same we have to mention BGA and just custom query within a room BGA, and here we have to mention what is the full size and required as per the document. They suggested to take 10 mil as a whole size. I just want to have 10 mil for all and 19 mil for the maximum. Okay, and okay, and then the next we have the design release the fan out control for BGA and how we want to have the fan style. You can able to control from here direction and what is the direction from the pad. We have uncenter and wire placement. We want to between page center and the track to be taken from the center of the pad. Uh, so I want to keep it same. There are rules which we need to carefully apply. The first one is clearance with rule, go to hairstyle, and this the control how we want to do for the fan. Okay, just click apply and okay. Once there is a rule got placed for this rule, now we are going to perform the fan out. To do so, the fan out go to root fan out, and I want to do the fan out for a component. You click on component, we'll get a pop-up window. You can see fan out without nets as we don't have fan out. Nets are not assigned. Want to enable this option and fan out outer two rows of pad. Yes, we want to fan out outer two rows pad. And if you want the escape routing, it means automatically placing the routings after fan out completion. Uh, also we need, but this option won't work while we don't have the nets assigned to this pads. Now let us assign the nets and you can have the escape routing. For assigning the net, go to design, netlist, edit nets and click on add. Just add a net to all the pins. Just click OK and click close. See all the nets has got net name has been assigned. Now we can get the escape routing as well. Go to root fan out and click on component. Just enable this into escape routing. I don't want this option. We don't have blind bias. Okay. Just click OK and fill the component. We'll see all the traces has got fan out and we have got escape routing as well. Okay. Which will be very good for the layout engineer to perform the routing. And just as we all mentioned, when you take the routing out of the trace, you can see the minimum trace width it's been taken. When I place a BR and when I take the trace back to the you know, uh, inside the suppose when the trace is entering, we have given 3 mil as a required trace PC automatically it is taking 3 mil. That is a useful thing of room inside the LTM where it enables you to place apply design rules for a specific area inside the RTM design. Okay, this is all about the how we can do the fan out inside the RTM designer. Now, now we are moving towards the next topic is uh, that gloss and retrace panel, which will be implemented in the RTM Designer 22. We'll access that gloss and retrace panel from go to panels and gloss and retrace is the panel is built here. Here we have a power panel. You can see we can able to take the hugging style. Is it pin 45 degrees are rounded, and we want to avoid any polygons rooms. So we can able to select these two options. And what is the gloss effect required, and what is the for the retrace, what is the width you should take. We can able to pick from here. Now let us park it in the right side of the designer. Now I want to do the some gloss effect for this group of traces. Let me select these traces. Let me enable a filter and tracks. Yes. Okay. And I enter tag, which will get automatically selected the traces. And let me close off all these which are not necessary. Uh, but you will find yes, yes. We have this one. I want to have 45 degrees and weak thing. Then they serve this and go to root and they say gloss selected, but it will be not much because we have said the effect as weak. It won't get that much effect. If you want to have the much effect on the gloss selected, you can use the option strong so that you can able to get uh, much more optimization in terms of routing. Now let us try with the rounded uh, round. I will do. I just go to take the net if I want to see if I want to have a rounder shape around this for this place. It's not a rounded. It is as per this. It is being following corner style, 45 degrees, and this one. If you want to have a rounded, just simply press take the shape and press for the mouse on the. Is about the any angle routing or a snake routing inside the RTM designer. If you have the gloss panel, you can just have the rounded and effort as strong. You take the trace and if you start routing it, but here start routing it here, the trace which is very big there. Let me uh, take it as just 0.75 and make it as any angle. Okay, and you can see here it is following the uh, design rules and it is helping us to perform the any angle routing inside the RTM designer. Okay, this how you can able to do the snake routing or any angle routing inside the RTM designer. Yes, this is all about the advanced routing and techniques uh, webinar. Now, to summarize our session today, we have showed how we can able to define the difficult pairs in the schematics and how we can do the routing and how we can also define the difficult pairs in the PCB data. And also we have showed how we can, if you have identical differential pairs, how we can do the routing for the group of two nets and then how we can copy and paste the same. And we have showed the length tuning and rating of sub-length tuning, and we have showed the active root. In the active, we have showed the length tuning of active root and and root guide, where you can able to specify the path of the trace and it will follow the tuning. And we have showcased you the BGA fan out. Okay, and followed by part where we have showed you how you can able to do the glass panel, how you can use a glass and retrace panel, and I showcased you the contour routing and the any angle routing, snake routing inside the RTM design. Now we are open for the questions. If you